So good morning students, welcome back. Today we'll discuss the topic Ohm's law. Okay, look students, Ohm's law, resistance, resistivity, conductivity, vector form of Ohm's law, and then after numerical based on it. So now first of all we'll start with Ohm's law. Okay, what is Ohm's law? Ohm's law, let's start Ohm's law. Okay, Ohm's law is about the conductor. A conductor is connected with a cell having potential V and switch K. Okay. When switch is on, current I will flow through the conductor. Okay. So Ohm's law states that at constant temperature and constant area of cross section, actually that is a constant physical condition that area of cross section should be equal throughout the conductor, temperature should constant. In this condition, okay, the potential difference at the ends of the conductor is directly proportional to the amount of flowing current. Okay students, see one more time. At constant physical state like area of cross section, this remains constant, and at constant temperature flowing current through the conductor is directly proportional to the potential difference of ends of the conductor, V proportional I. Okay, it means on increasing current, potential difference will increase. Okay, on decreasing current, potential difference will also decrease. Understood? On increasing one factor, other factor will also increase. And on decreasing one factor, other factor will also decrease. Suppose we are having two batteries. Okay, we are having two batteries. First is of 10 volt, another is of suppose 1000 volt. So which battery can generate more current? Okay, obvious. Suppose we are having two batteries. One is of 10 volt, another is of 1000 volt. Okay, so which battery can generate more current? Obvious, 1000 volt. This can give more shock and this can give less shock. Same like on increasing potential, current will also increase. Now whenever you remove this proportion sign, we'll always use equal and constant. Here I'm going to use a constant R. R is constant. It is called resistance of this conductor. It is resistance of this conductor. So now students, after that we'll discuss about only this factor R, and V equals to IR, that is the mathematical form of Ohm's law. Okay, now students, we'll discuss about R, that is what? Resistance. Actually resistance, now students, V equals to IR, that is the mathematical forms of Ohm's law. Now R is constant, it is said to be resistance. It is said to be resistance of a wire. Now we'll discuss about R. What is resistance? That is the main topic. Okay students, so let's start the resistance. Look students, resistance is a property of resistor. It is a property of conductor which opposes the flow of charge. Okay, it can stop the current, it can minimize the current. So resistance is the property of conductor, property of resistor that opposes the flow of charge in a conductor. Okay, so V equals to IR. On account of that, its mathematical form will be what? R equals to V by I. Okay, the ratio of voltage and current, the ratio of potential and current is said to be resistance in mathematical form, and we can define as it is an hindrance or obstruction in the flow of current. It opposes the flow of charge. Okay students, now what should be its units? This potential having unit volt and current having unit ampere, and volt 1 volt by 1 ampere we can write as Ohm. That is the name of scientist. Either we can make this symbol, we can write Ohm, either we can make this symbol. On behalf of the name of scientist, the unit of resistance is what? Ohm. Okay. The resistance of a conductor wire mainly depends on two factors. This is the conductor, its length small l, its area of cross section is A, and resistance R. So first of all, resistance of a conductor wire is directly proportional to the length. It means for long wire resistance will be more, and for short wire resistance will be less. Okay, on increasing one factor, other factor will also increase, and on decreasing another factor, this factor will also decrease. Now students, the second thing, point, resistance is inversely proportional to the area of cross section. It means for thick wire, if area of cross section is more, that will be thick wire. For thick wire, resistance will be less, and for thin wire, resistance will be more. When we combine from, we can write equation first and second. When we combine, we will get R proportional L upon A. Okay, resistance directly proportional to the length and inversely proportional to the area of cross section of the given conductor. Now students, whenever we remove this proportion sign, we will always use equal and constant. Here I am going to use a constant. This constant is represented by this symbol, that is, this symbol is said to be rho. Okay, this symbol is said to be rho, and it is said to be either resistivity, or it is also said to be a specific resistance. Okay, this is said to be rho is constant, it is called resistivity, or it is said to be specific resistance. This rho does not depend on, this rho does not depend the size of the conductor. This rho depend only on nature of the conductor as well as on some external factor like pressure and temperature. Okay, what should be unit of this rho? Now see the formula students. On account of this, R equals rho L upon A. Okay, we have to find the unit of resistivity. So what should be unit of resistivity? R into A by L. The unit of resistance, ohm, area, meter square, and length, meter. Meter and meter cancel out, so finally we will get ohm into meter. We can make this symbol also ohm into meter. So what is the unit of resistivity? Either specific resistance, ohm into meter. Now students, how can I define this rho? Look students, suppose if length of this conductor wire is unit, like one. Now students, we'll define this rho. Okay, if length of this conductor is 1 meter and its area of cross section is 1 meter square, suppose if both is unit, in that case, if L is unit, area of cross section unit, in that condition R equals to rho. So what should be the specific resistance? It is defined, okay, as the resistance of a conductor wire in a specific condition when area is unit, okay, and length is unit. Area and length both are unit. In that condition, resistance of a conductor wire is said to be resistivity. Okay, it is also said to be specific resistance, and its unit will be ohm into meter. Okay, friends, we did Ohm's law, resistance, resistivity. Now discuss about conductivity. See, we are having two important terms. The first is conductance. It is represented by capital G. What is conductance? The reciprocal of resistance is said to be conductance. G equals to 1 upon R. R is said to be resistance. The reciprocal of resistance is said to be conductance. Okay. We know what is unit of R, resistance, ohm. So what will be the unit of conductance? 1 by ohm. Either when we transfer ohm, it become ohm inverse 1 by ohm or ohm inverse. Okay. When we take reverse MHO, that is called mho. That is also said to be the unit of conductance. 1 by ohm, ohm inverse, mho, or 1 by ohm, either ohm inverse is also said to be Simon. It is represented by S. So Simon, mho, ohm inverse, 1 by ohm, all are the different unit of conductance. The reciprocal of resistance is said to be conductance. On other hand, conductivity, that is represented by the symbol sigma. Look students, reciprocal of resistance is called conductance, but the reciprocal of resistivity, either reciprocal of specific resistance, is said to be conductivity. 1 by R is G. but 1 by rho is sigma. The reciprocal of resistivity is said to be conductivity and represented by this sign sigma. We know, students, we found the unit of resistivity is ohm into meter, transfer, ohm inverse, meter inverse. So what should be the unit of sigma? Ohm inverse or meter inverse. Okay, and ohm inverse we can replace as Simon. So Simon meter inverse, that should be another unit of conductivity. Okay, students. Now, students, finally we will discuss the most important part, vector form of Ohm's law. Okay, students. Now, students, will discuss the vector form of Ohm's law. Look, students, we are having a conductor. Okay, its length is L and its area of cross section as suppose small a, or we can take capital A, and E is the electric field applied at the ends of conductor. Okay, in that condition, what should be the potential difference? V equals to EL. L is the length of the conductor, E is the applied electric field, and V is potential. Okay, on conductor. Now, students, still applying Ohm's law. What is simple form of Ohm's law? That is V equals to IR. Okay, we'll make one change. We know what is R, rho L by A. Here I'm going to put the value of R, I as it is. What is R? Rho L by A. Okay, students. See one more time. First of all, we'll find potential at the ends of conductor, EL, where E is electric field and L is the length of the conductor. Then I applied simple form of Ohm's law, V equals to IR. Okay, students. We know what is R, rho L upon A. Here I am going to put rho L upon A. Okay, then after give them as equation number third. Now, students, compare first and third. Look, students, left hand side equal, right hand will also equal. So from first and third, here I am going to write as EL equals to I rho L upon A. Look, students, L to L cancel out, will get E equals to I rho by A. Now, students, the important terms, I upon A, the amount of current flows in per unit area of cross section of the wire. Okay, current flows in per unit area of cross section wire is said to be current density. Okay, it is said to be current density, and that is represented by J. So I upon A is J, and that remains rho. So we got the first form. I want to clear you what I did. Here we make one change, I upon A, that is said to be current density. Okay, the current flows in per unit area of cross section of wire. The amount of current that flows in per unit area of cross section of wire is said to be current density. And now, students, so I upon A become J, current density. Now we'll make the final change we just did. Rho is sigma is what? 1 by rho. Reciprocal of resistivity is called conductivity. So this rho become 1 upon sigma, and finally we'll get cross multiply J equals to sigma E. So we got the final form, cross multiply sigma multiply with E, sigma E. So vector J equals to sigma vector E, where J is current density, sigma is conductivity, and E is electric field. This is the vector form of Ohm's law. You can check numerical based on Ohm's law. Okay, look, students, the resistance of a wire is 5 ohm. We are given a conductor wire. Its original resistance is what? Initial resistance is what? 5 ohm. If its length increases by twice, it means if initial length L1 is L, okay, so what is the final length? It's 2L. It increases to twice, L to 2L. Okay, then what will be its new resistance? Actually, you have to find its new resistance. Let initial area of cross section is A, A1 is A, and A2 that we have to find also. Generally, what happens, students? Okay, if you think that resistance is directly proportional to the length. On increasing length twice, resistance also become twice. So resistance is directly proportional to length. If length is double, resistance also double. So generally we'll go with 10 ohm. Okay, but that is not the correct option. Why? Because when you increase the length, when the length increases, okay, with same time this area of cross section decreases. It changes. Whenever we stretch something, suppose we stretch the wire, its length increases, but area of cross section decreases. It becomes thin. That's why this will not work. So students, how can we solve? Look students, I'm going to solve this question and we'll find the correct option. See, when we stretch the wire twice, its volume does not change. So initial volume equals to final volume. We know the formula of volume, area of cross section into length, A1 L1. We can write A1 L1 and we can write here A2 L2. A1, what is initial area of cross section that we assume as small a? Initial length we are given as L. Final length become twice and area of cross section we have to find. So what will get students? Suppose this is A2. So L2 will cancel out. What should be A2? A2 will be A by 2. See the important point. On making length twice, area of cross section become half. It decreases. Okay. So now students, we know R1 equals to rho L by L1 by A1. This is for first wire. What will be for second wire? R2 equals to rho L2 by A2. Suppose first 10, second. First divide by second. So R1 by R2, rho to rho cancel out. What is L1? L1 we are having as L. A1 we are having as A. Okay, A2 comes in multiplication. What is A2? A2 is A by 2. So that's A2 is A by 2. Okay, and L2 is what? 2L. Okay, L2 will cancel out, A2 will cancel out, 2 2s are 4. Okay, so R1 by R2, 1 by 4. And we know what is R1. This R1 we are given as 5. So R2 into 1 R2, 5 4s are 20 ohm. So what is the final answer? Which one is the correct option? Option C is the correct option, 20 ohm. If the length of the conductor wire is twice, then its resistance become 20. So what we got? Its resistance become R proportional to L square. In that condition, if length is twice, 2 square 4, resistance become 4 times. So remember, whenever the students we make some change in length, area of cross section will also change. On account of that, resistance will also change. So this time we'll get 20 ohm. Such type of question will come in that competition examination. Okay, so you have to know everything.